So in the last video, we got so far with that when we load the page, um, we've added all the event listeners, so we can click on mice, etc. When the page loads, the cat is actually put into the actual grid, uh, and we can toggle the mice on and off like that. But when we try to move the cat, nothing happens. Actually, we get a reference error because the move cat function hasn't been declared yet. So let's add the move cat function. I'm actually going to add a fair amount of it. So hold on. So I've copied a fair amount of the move cat function in here, and it's a lot of the algorithm is going to be fairly simple for you to understand. It's just got a math random, which is producing a random number, and then based on the random number, we're deciding whether to move the cat up, right, down, or to the left on the grid from where it is in its previous position. Uh, and these x change and y change variables are just a way of specifying that numerically. So if here's cat and I want to go up, I need to reduce my y coordinate by 1. Yeah, so that would take me up 1. Likewise, if I want to go right, uh, I would increase my x coordinate by 1. And that's what I'm doing here, is if the original cat position is x, the new cat position is cat position plus x plus the x coordinate plus the y coordinate. Now notice that actually the way this algorithm is set up right now, only one of these can change at a time. We're not changing them both. You can either change the y or the x coordinate, but not both. But I have both of these because the random number can produce a move either to the left or the right or up and down, or comparably a move on the x-axis or the y-axis. Another thing to know, cat position x has been defined up here as a universal, as a global variable, and it was used also to specify the original location of the cat. So then after we've actually defined the new position of the cat, then we can just change the c to that new coordinate right here in this line. So let's actually move the cat around. Notice one thing that's happening here is that the original cat, it's like leaving tracks, which we don't want, so we need to get rid of the where the cat was before. And we can do that by adding another line of code, like so. And now, if we move the cat around, the cat tracks don't stick around. Now let's move the cat around a whole bunch and watch the console. Notice that we're getting a type error. We're getting an error here. And so what's going on here is that sometimes when the cat gets to the end of the edge of the grid, the direction that he's supposed to move in, according to the random number generator, is off the grid. And so that's why we're actually getting these errors here, is that it can't read the property of a cell that's undefined. It's actually gone past it's basically an array out of bounds error. So we need to actually add the code in there that will invalidate any direction where the cat is trying to move off the grid. So let's add that next. And this is going to be just a simple conditional. And like so. And this conditional is calling a function valid position, which is passing the proposed new x and y coordinates, and we pass it to a valid position function. And in this valid position function, we've passed the coordinates as parameters, and we see here whether the x position is more than -1, because it has to be 0 or more, and it has to be less than the max y value, the maximum number of cells, which we figured out. It's a global variable, and we figured it out up here when we ran the init function. Likewise, if we have to know whether it's within the x coordinates, it also has to be within the y coordinates, and here we're figuring out whether it's more than -1 on the y coordinate and less than the max y value. If it is, then we return true in the function. So, if this evaluates true, then we can run what's inside the conditional. However, if otherwise it returns false, and then this stuff won't run. So now if we run cat again, just keep clicking cat, you can see that no matter how many times I click here, I'm not generating an error in the console. And with these functions in place, the very basic simulation is done. We can add mice however much we want, and we can move the cat around, and he's eating the mice, effectively eating the mice. But what you can see is they're there. It actually takes the cat a little while to actually find all the mice, and that's because he's moving randomly around on the screen. He doesn't know really where the mice are. He eats them only if he just actually runs into the actual square. So in this next little bit of the video, I'm going to show you what the cat is going to do is, if he's actually right next to a mouse, like say right here, he'll be able to sense the mouse and immediately eat him. Because right now he's not, well, he did it that time, but here I'm clicking the mouse. The cat doesn't see it. So another way of putting this is if the cat's here, actually let's reload the page. The cat's here, and there's a mouse here. We're going to create a little function that can sense all of the surrounding cells around the cat and detect if there's a mouse in the vicinity, and then move on to that cell and eat the mouse instead of moving around randomly. And this is important algorithm, or little snippet of code for you to know, because you're going to need this on the evolution assignment as well, because when you are trying to figure out whether to kill cells or to grow cells in the evolution assignment, you have to be able to determine the cells that surround the other cells that are in the vicinity. So our new code is actually, instead of just randomly repositioning the mouse, we're going to first run a call a sense mouse function. And this function returns a mouse direction. So if there's a mouse in the vicinity, it's going to return a new set of coordinates to mouse direction. Otherwise, it returns false, that they couldn't find a mice. Then we put in a conditional. And it's going, if there is a mouse direction we should move in, meaning there's a mouse in the vicinity, then the function returns the x coordinate, which is, it returns basically an array, which is the first position in the array for the x direction, and the second position in the array is for the y direction. So again, if originally the x, or the change in x or y change was determined randomly, with this new method, we sense if a mouse is in the vicinity, and we provide the new x and y direction by what's returned by the sense mouse method. or function rather. So let me copy that new sense mouse function into the code base, and I'll explain it to you. You want to know this pretty well yourself because you're going to use pretty much the very similar code for sensing the cells that are in the vicinity of other cells in the evolution assignment. So sense mouse gets called here, and let's say we're starting here, and maybe let's say we have a mouse here probably. And the way we detect what's in the vicinity is we start from the top left and work across and down. So we look at this row, then we look at this row, and then we finally look at this row. Yeah, so we start with -1 and -1. So if we wanted to look at this particular coordinate, we would find the cat's current coordinate and then subtract 1 from the x value and 1 from the y value to look at this square. And then if we run this nested loop here, we're effectively looping first through the x-axis. So we start up here, and then the internal part of the loop counts up along the y-axis. And actually, I see a problem with my comment. It's actually not working from the top and then across. It's working from the first, from here, working down like that, because this y value goes from -1 to 1 here. So it's actually starting from the top left and work down and then across. And let's stretch this out so we can see that next line of code without seeing that stuff wrap as much. So if this nested loop is checking the squares in the vicinity of the cat, then when we are on a particular square, we have to see whether there's an M in that particular location. And you can see this particular snippet of code is doing that. We're specifying the row and the cell, and then we're seeing whether the particular row and cell, and then we're seeing whether the inner HTML in that particular cell has a mouse in it. Yeah. So let's actually simplify that a little bit. We can take this out for the time being because I'll explain this piece of code a little later in a second to you. So basically, when we get to a particular cell, we're just seeing whether a mouse is in that particular cell. If there is one, then we return the coordinate or the change that needs to be, that the direction the mouse needs to go in. It's basically an array back to this function. If there isn't a mouse, if we go through all the squares and no mouse is found, then we just return false, so that when we get here, if false, then we just use the regular random number that was generated and not these new values. So let's actually run this code, and we should see the cat immediately eat the mouse. Oops, didn't see him. So now let's run the code. Let's just run it and see what happens. So if I put a mouse here, let's see whether the cat actually, he does move down, or if I put him here. So basically, the cat is moving and sensing the mice. Okay. If I go here, though, notice that we generate an error. We've got to Yeah, we've generated an error. And that's because when the mouse gets to the side of the thing, um, the side of the grid, we're then doing that full look all the way around, and uh, we're looking all the way around in this vicinity. But these particular squares are are not yet valid squares, so we need some sort of validation so we don't check those squares, and that's what this part was right here. We're just basically running the valid position, calling the valid position again, and then wherever we are on the grid, seeing whether it's valid or not. If it's not valid, it returns false, and then we don't execute any more of. We don't look. We don't actually look any further in the conditional, and we don't then generate the error. So now, if we've added that and save it, and run it again, put some mice in. Notice that it doesn't throw an exception. And there we go. This notice that while the algorithm allows the cat to see the mice, he's not really smart, because he'll occasionally skip a mouse, or he'll forget where a mouse is. So if we run this, now he's forgotten this mouse here, and that's because it's just a limitation in the function. We could build it so the cat remembers that he needs to backtrack, but this is just a limitation of it. Anyway, to sum up, you've learned a lot of things, all the things you're going to need to know to build the evolution simulation. You first learn how to execute an init function that will find the rows in your table, and then you can use the init function to call an add clicks function, and then add all the event listeners to the cells to the cells in that table. And those event listeners let you click on the different cells and toggle the mice. Although in your case it's going to be toggling cells alive or dead. If they're aqua colored, they're alive, and not aqua colored if they're dead. And in the event listener, we learned how to associate different events with the event listener, and then call functions that would then do things to the element. In this case, we're putting an M in the element. And we also learned to use the this parameter to be able to actually pass a reference of the element to the function, so that we can we have a reference to it and we can update its content. And actually, that's the sum total of the new syntax that you're learning in this sort of JavaScript syntax that you're learning in this assignment, is the add event listener and the this parameter, I think. But then the rest is just working with JavaScript well enough that you can, and the add event listener, as well as knowing how to access the rows and the cells in a particular table. But the rest is just JavaScript that you already know. The tricky thing, of course, is being able to sense the cells around an existing cell. And I've given you a function that you can modify for the evolution assignment that allows you to do that. And you also, of course, need to be careful when you're looking around the cells not to sort of call cells that are off the grid. So you need something like a valid position function to run, so that you don't start trying to refer to cells off the grid. Okay, I hope these two videos are helpful to you. This is a challenging assignment, but the nice thing is there's not a ton of new JavaScript language or syntax. No, it's just working with that new syntax and and understand these other little mini algorithms so that you can figure out what the surrounding cells are around a particular cell, uh, as well as not straying outside the bounds of the grid. Okay, good luck with this assignment. Thanks for watching.